Let us learn few activities related to physical properties of metal. One of the physical property we had learned of metal is lustrous. Metals have lustrous nature. For this activity, we need to take samples of iron, copper, aluminum and magnesium. Okay, they should be rubbed with sandpaper. That is mainly to remove their oxide layer. So when we rub with the sandpaper, we can observe iron, copper, aluminum and magnesium, they shine. So this indicates that metals have lustrous nature. Now, second activity, activity 3.2. So this activity shows that most of the metals are hard and few metals are soft. For this activity, we need to take small pieces of iron, copper, aluminum and magnesium. We should try to cut these metals with the help of a sharp knife. When we try to cut these metals, iron, copper, aluminum and magnesium with the help of knife, it is not that easy. As it is hard, it is not that easy to cut these metal with the help of knife. So this indicates that most of the metals are hard. At the same time, if we consider sodium, it can be sodium, lithium or potassium. Do you know, if we use a knife to cut these metals, very easily we can cut these metals. Sodium, lithium and potassium. So this indicates that most of the metals are hard. There are few metals like sodium, lithium and potassium. They are soft metals. Next we'll study activity 3.3. So this activity shows a malleability nature of metals. This is one of the physical property of metal. Metals are malleable, means when it is hit with a hard object, they become flat. They can be converted into sheets. For this activity, we need to take pieces of iron, zinc, lead and copper. Now, with the help of a hammer, we'll hit these metals. Iron, zinc, lead and copper. Do you know what will happen? They become flat. Means they can be converted into sheets. So this activity shows that metals are malleable. Okay, then activity 3.4. List the metals whose wires you have seen in daily life. We know one more physical property of metals. Metals are ductile. Ductile means they can be drawn into wires. Here they have asked a question. Name the metals whose wires we use in our daily life. See, we use the wires of iron, copper, aluminium, lead. Especially lead wire is used for soldering. Okay, for soldering purpose we use lead wire. So these are actually few metals which can be drawn into wires, means which are ductile. Now we learn activity 3.5. So this activity shows another physical property of metal, that is metals are good conductors of heat. For this activity we require a stand. We need to take a metallic wire of aluminum or copper. Aluminum or copper wire is actually required. It should be fixed to this particular stand with the help of a clamp. We need to take a burner mainly to heat that particular metal. Then the tip of the metal is fixed with a pin. Okay, how are we going to fix the pin to this particular metal? Through wax. You can see here somewhat yellowish color wax has been placed. To that a pin is actually fixed. Okay, now so what can be done? Here, with the help of this burner, we'll start heating this particular metal somewhere in this particular region. Okay. Now, metals are called good conductors of heat. What they will do, they will allow the heat to pass through this particular wire. When the heat actually reaches this tip region, the wax will melt. When the wax melts, what will happen? The pin will fall. So, this indicates that metals are good conductors of heat. When we heat this, in this particular part of metal, the heat will be transferred to the tip region. How we can make out the heat is transferred to the tip region? The pin that is fixed to this particular metallic wire with the help of the wax will melt due to heat. When the wax melts, the pin will fall, indicating metals are good conductors of heat. Now we will learn activity 3.6. So with the help of this activity, we will study another physical property of metal. Metals are good conductors of electricity. Yeah. For this activity, we require a battery. We require metal, we require wire here. Then we require bulb. We require a switch. Then there are two clips here. So between these two clips, any metal sample can be placed. So what should be done here? Now we'll take few metal samples. It can be of copper, aluminum, like iron, like that. Okay, so you can consider this as actually that particular metal sample. So this will be placed between these clips A and B. Okay, now we'll turn the switch on. When we turn the switch on, if the bulb glow, that indicates this metallic sample has conducted electricity. Means it has helped the current to move from one one end of the wire to the other. Okay, now so whenever I actually place this metallic sample, okay, it can be aluminum, copper, iron, any metal wire, when I place it between A and B, do you know what will happen? When I turn the switch on, the bulb will glow. When the bulb glow, that indicates metal has conducted electricity, means it has allowed the current to pass through it. Okay, so that the bulb can glow. Suppose like whatever material I place it here, suppose it doesn't allow the current to pass through. Okay, how I'll get to know the current has not the current has not passed through that particular material? The bulb doesn't glow. So that is an indication that particular sample which I have used is not a good conductor of electricity. But in the case of metal, whenever the metal sample is actually placed between A and B, and when the switch is actually turned on, the bulb will glow, indicating metals are a good conductor of electricity.